Everybody sounds good. Okay, so thanks for that introduction. What's up, Marlon Pearson? I walk all the way from Florida. Okay, so before I get started, it's always a competition for people's attention in these meetings, but so there's a lot of stuff going on today, and probably recording this for posterity, so we can come back 25 years from now and see which one of these things was the most important. So, of course, the iPad 3 announcement today, Big Bang, leaving Colts, and also, yeah. And also, we probably got confirmation about our knowledge about the fundamental nature of the universe. So, this is a weird picture of here in the lab. So, you notice that experimental lab is, of course, the closing of the accelerator, but one of the last experiments for confirmation. So, anyway, I hope this talk will fall somewhere between Big Bang departure and iPad 3. So, or probably, to be honest. But anyway, what I do is I am the leader of a group in the building next door called Science Gateway Group. We have a number of people on the team, besides myself, project leader, which means I talks and write proposals, wonder why all the JIRA tickets are being unfilled and things like that, and some coding when I have the chance. Suresh served as a principal software architect, particularly for the Airavata software we're going to talk about a little bit later, and then we have Untitled Chapter, Marlon, and one who are senior staff members. So we're also always interested in working with the grad students. A lot of work that's Beth alluded is funded by Exceed, so I hope everybody knows what Exceed is. If you don't, it's a big collection of supercomputers put together by high-speed networks across the United States, and has some bureaucratic overlayer and also a software overlayer for providing that something like a uniform access to. So a lot of our funding comes from that. So all these people here. So one of the ways so Exceed is probably the biggest thing, but that's not actually for software development and those sorts of things. So this Open Gateway Computing Environments project, which is in the title, I think I forgot to ask, but that was in the title. That's an NSF project that actually funds most of the software that I'm going to talk about. So the OGC project is a thing that NSF funds, and then we built software as part of that project and turned around and contributed it and created two Apache incubator projects, Airavata and Rave, which I'm going to be talking about most about today. So to give you a picture, if you're not familiar with what we're talking about when we mean science gateways, these are interfaces to remote computing resources or remote scientific computing resources. Typically, these are done through the web interfaces, browser interfaces, like the upper left here, that's a screenshot of Rave with some gadgets in it. So besides having those visual displays, you can also manage users and groups and things like that within the Science Gateway framework. On the bottom right is a screenshot of a workflow composer tool called Adobe. That's part of the Airavata suite of tools that I'll say more about later. So this is something else that a Science Gateway might do. You might have an application that runs, in this case, it's a web sort application, we're making a web version of it, but you might have a version of this that runs on the desktop that allows you to put together different applications, different services that are not running on the desktop, they're running like C or running OSG or some other place, and build a composite scientific application of those things. So that's just to give you a quick insight into what kind of stuff we're actually talking about today. So all this exists on top of or as part of a much larger activity called Cyberinfrastructure And so this is a layer cake diagram. You should look at it bottom up. So the foundation here, the Exceed we've alluded to. Also, this could be the Azure Cloud, Amazon Services, EC2, S3, and so on. These provide your foundational. On top of that, you have the access layer, the middleware. These are the interfaces to your cloud services, your grid middleware. These are the things that you use to actually access these machines from services or whatever you will access these. So the top two layers are really what we are doing. And of course, I drew this, I made this figure, and so I gave it this disproportionate amount to the stuff we actually do. But, you know, you should understand that all this stuff is really a significant effort. And all the stuff here that kind of relegate to the side of being, these are things that are complementary work that we don't do. These are, of course, all significant efforts. So the point I want to convey here is that a Science Gateway is not just a web interface. It's not just the thing that runs in your browser or even the complementary desktop. But there's also an entire layer of value-added services that we have to, and other capabilities that we have to provide in order to make the gateway work. So in a nutshell, you can think of this part, a lot of the stuff as being Apache Rave, and a lot of the stuff as being Apache Airavata. Okay, so collaborate with a lot of people. So a lot of these tools, especially the work, so Rave is a fairly new project. The Airavata tool suite was actually originally developed in a project, the lead project that many of you are familiar with, where they were targeting workflows that ran in atmospheric sciences. And so we've taken a lot of that software, really put a lot of work into generalizing it and using it in lots of other different domains with lots of different other collaborators. So this list of people is a wide variation, so it ranges from things like ultrascan, where we have to, we're helping them with their grid job submission and data analysis applications that they use for analyzing data that comes off of the analytical ultracentrifuge, basically spinning around macromolecules and finding out what they're fitting their results to classic physics flow equations, applying flow properties of these molecules. So they do all their data analysis on Exceed, also local resources. This thing is hit all the time. So this is we have to worry here about last mile issues that only show up after you've been doing hundreds of submissions or your submission hundreds of hours, things like this. You have really rare, hard to reproduce or other types of problems that crop up and making sure those jobs run. So this is an example of something that's really pushing how reliable and robust the code is. For some of the others, so GridGem also is another one that's used in regular production. Some of the others, Link Consortium's Astronomy Portal, this is to build a, some of you have been involved in this, is to build an imaging processing pipeline so modern astronomy works by putting a camera on the telescope and the camera takes pictures. So these images that come off are in a format that has the data embedded into the image, and so you have to do a lot of processing on that image to remove instrument features, other problems that might have arisen from the atmosphere not being perfect and so on. So it's a whole sequence of steps that has to be done. This is what this particular WIN ODI image processing pipeline is deploying the software to a portion of that entire project. So that's something that's not as mature as some of these other things. It's something that's brand new. And we also have put in a couple of collaborations that I haven't even got started yet. So D-Lab is one that we hope to start soon, where we're working with a group who's trying to use quantum mechanical diagrams of planetary materials, which you can't do for very long labs because they require such tremendous pressure. Anyway, lots of cool things that lots of people doing really cool science stuff that you can map to these general purpose workflow tools. So what I worry about a lot, after doing this for a long time, is you start to worry more and more about working with the same code base for a number of years, and working the same types of problems for a number of years. Start to get a certain perspective, I guess. So when I was in grad student, I wrote my code, physics, I wrote my code and got my publication done of it and handed it off to the next poor guy who had to figure out what the heck I was doing. Managed to figure out what the heck I was doing. He graduated, passed it on to the next guy, and so on. So that's probably fine for a certain level of coding, but if you really want other people to reuse your software, if you're really doing something that you want, you're really building software for a community, you have to start worrying about software engineering and governance issues. Some of these larger things that you don't have to worry about so much even as a young developer. So the first thing, and of course these are not just problems for science gateways, but also cyber infrastructure in general. The first is reusability. So science gateways, a lot of the core problems by description are maybe not that hard, or they don't sound that difficult. It's only really when you try and run them lots and lots of times, when you want it to scale over time and under load, that some of these hard problems start to come up, as I mentioned with ultrascan. So you really have to fight, convince people in the first place, what we rewrite this, we use what we have. Because if you do, not only take advantage of all of our experience, but you'll have, you or your boss will have hope for sustainability. So a lot of problems with gateways arise from software in general, arise from people not doing the right, not following the right software engineering approaches to make your software understood, open source, reliable, well packaged, all these other things. And then also, software can get too closely tied to individual developers. When the developer graduates or leaves the project or whatever, suddenly you have to scramble to sustain what you have. And a lot of projects fail at that point. So there's a very long report from a multi-day meeting about sustainability and some of those aspects here. One aspect, though, that I think, so if you go to NSF, program officers and so forth, they're very concerned about sustainability, particularly reusability. Governance is a word that they're starting to warm up to as well, and I think this is really been missing in a lot of open source cyber infrastructure projects that the NSF has funded and other places other people have funded. So the governance issue is, how do you make decisions about the software? What features should the software have? What capabilities should it have? When is it time to release? Should I release because I need to? You said our program plan that we would release, during supercomputing or something like that, or do you actually have something we've been really guilty of in our project in the past? But if you have an actual way for deciding when the software is suitable and for release, and you have actually people who are stakeholders in the project to say yes, it's ready, or no, it's not ready. More importantly, also, governance is how do you handle contributions? So if you've got a community of code, or a community around your code, people will want to see patches, or bugs that need to be fixed, these sorts of things. So how do you actually get them into your project? How do you handle some of the legal issues? And if you're really getting good patches from somebody, want them to join your project, what's the process for actually converting people who like the project, identify your project, so forth, into actually people who make decisions about your project? First bullet. The governance issues are one of the big problems that we want to try and solve. And so it's one of the things I'm going to keep getting back to in this set of talk. So, in order to address those three issues in the previous slide, within the OGC project, we decided to fund the entire, what our proposal based on is funding the entire life cycle of the software, or Airavata Rave software, by not just having the developers, not just paying for the people who write the code, but also paying the people who use the code, deploy the code, like UltraScan project, Rave project, and so on. Then actually funded it as part of the project, so that we're all accountable for all the way through the cycle. So we don't just wrap something up, put a tar on the website, and then go on to our next thing, but rather we are responsible, not even for doing, not just for doing simple testing, but actually doing all the integration testing, making sure this is going to work in production gateway environments. And then from that, we get more requirements. The cyclic process. I guess the challenge we have right now is not doing this for individual gateways, but actually getting all of them synced into one cycle. So, as far as governance goes, one of the things I'm trying to convince you of, and other people, is that you really have to go beyond just open source to really develop an open community around your code. So, there are, of course, lots of nice tools for supporting open source projects like SourceForge, GitHub, Google Codes, etc. If you're not using them, you should. Will use their tools for version control and bug tracking and all the other stuff. That's not really, you know, if you contribute to a project, a SourceForge, for example, they have a helpful list of open source licenses, free software licenses you can choose from. They don't really mean anything. So we're really talking about going the next step beyond this to figuring out how to build a community around your code and why you want to do that. So you want to do that because basically this is hopefully going to address some of the challenges a couple of slides back. Diverse community developers increases the probability that you'll get reused and software will be sustainable. But you can't really have diverse community of developers without governance. You can't have, on the one hand, you can't have this Wild West thing where everybody's just getting access and writing, making changes directly to testing in without any control or Git or whatever you want to use. On the other hand, you want to find a way to reward people who come to your project, give them some say in your project, not maintain this tight-fisted control over your project. Anyway, so to reiterate here, if we think if you get governance right, then you can solve a lot of reusability and sustainability problems with our software. We hope this is a model that we can other people in the cyber-infrastructure community adopt. So I want to give credit to that claim that we invented this idea. So these are some prior art here. CDIGS was a project that NSF funded. The global, or the Globus Consortium, give it a community model. Zero, Sakai, and Koali are all institutional level organizations. Let's, I call out the Parallel Tools platform specifically because Jay Alameda, who some of you know, is involved with that. But actually, Eclipse has a nice open source community that surrounds it. It's a bit different from Apache in that everything actually works inside of it. Build things to work on top of Eclipse. quite appropriate for our project for various reasons. Another one that's not appropriate, but also very interesting, is this project called Enzo. So Enzo is a code that's been around for 20 years or so, and it's used by Mike Norman, the big shot physicist at San Diego Computing Center, and his proteges and colleagues and so forth. So they're simulating the universe, or the macro structure of the universe. So it's a bit different aim than say zero. So they're actually going to great lengths to figure out how to organize all these people, maybe 50 or so people who are using Enzo, maybe 100 people around the world using Enzo. So they're putting a lot of effort into governance model, or that open sourcing, making an open community around that code. I thought Brian O'Shea's talk at TG11 was very good. It's also very different from systems. It's also very different from cyber infrastructure generally. That here the code has to, you're not building job submission, or job management code, but rather you're trying to reproduce scientific results that have 20 years or more behind them. So this is not going too far down this path. It has some very interesting differences from some of the other models and open community models that I have listed here. So finally, we have the Apache Software Foundation, which normally doesn't deal with scientific software or cyber infrastructure. There was one group that we started building up a collaboration with, that's by Chris Matten out of JPL.
So Marlon,
Yes.
I understood Hub Zero. These are
I'm not intimately, I've heard the right word, not quite gossip, but, stories on the side, problems that Indiana has had with the IP restrictions that Zero version has imposed. And, I'm not saying that they're at different levels. This is also, I was trying to point out, a different level of organization. The universities, they always get together and give each other money to set up this consortium, whereas we're way down here, a little band of rebels trying to.
community.
Yeah.
Stops before.
And so, but that is, that is actually a thing I'll get to, that Apache is here it's, these universities trying to get together and build open source software, and, for sharks, we can get in the room with them, whereas here we're all friendly. But no, here actually, Apache is a neutral playing field. It was specifically created, I have a slide, specifically created for IBM and Oracle and some of these other people, but for these other people to work together on software of common interest, where they can have it licensed in a way that they can share the software and work in a collaborative environment, and then build a tool on top of it that they can sell. So basically, I think the model for Apache, for maybe not for science gateways, but the model for big companies is, let's push some of our software stack out to the community, let them support it. I guess Triton is another example. Just let them support it. Then we'll build tools on top of it. But we can't really afford anymore to maintain the whole all the way down to the bottom of the software stack. We just want to sell value-added stuff. I guess I'm not, but I'm not. Yeah, so that was an important. That's back to your question. That's an important thing, I think, that Apache specifically created to allow those types of collaborations. So you would not run into these problems of this consortium They wanted to claim intellectual property. People have to go down the road to
Yeah. But Apache doesn't have the equivalent of IDO.
Yeah, they're not trying to latch on to the next. They do have a legal department, they have a legal department. They're more, the other way of making sure that. Follow the bylaws that everyone's agreed to. We started 2 projects. If you really want to, I'm not going to go into great detail about either of them. If you really want to learn more, join the mailing list or come over and see us for demos or first a bit about Airavata. My point here also is to tell you, by telling you a little bit about code, if you see something that's interesting to you, want to get involved, that's exactly what we want. So, I'm not trying to give you every last detail of here it is in a broad outline, and if you really want to learn more, you get involved, and if you really want to get involved, you become a member of the project. Top of the site-scaling software for maybe one here, and if you want to see the website, you can go to airavata.org if you want to join the mailing list. And it's an open mailing list. One thing that I like to emphasize, again, the interesting thing about Apache is that all communications are open. So all discussions on Apache projects occur on the developer list. There are no backroom conversations. There's no well-run Apache project doesn't have backroom conversations where people decide we're going to do this now and so forth. But rather, everything is discussed on and necessary voted on the mailing list, which is publicly. And by search engines and so forth, so you can't, all your opinions are a matter of public record. Airavata has several different parts. Next thing I showed you a screenshot of. This is also the beginning, as we had the this is also basically a tool for composing workflows, which are boxes here represent typically services that run files in and out, and so on. GPAC is a service factory that wraps landline applications, so we're typically dealing with these are really non-visual applications running with so it's really asynchronous. So you have to have also this messaging system. So it's WS Messenger. It basically provides a system where notifications can flow between different components. So for example, subscribers on a event list. composer, which can also be used to monitor workflow, but you could also build other application recipients, or you could also monitor through the web interface. So I'm not going to describe this in detail. Recent workflow we put together in collaboration with James Berry and his team at Iowa State. I mentioned a lot of these things when we see. Not going into the detail, which I each of those codes is command line application. Could be here that we're running all the same machine. It could actually be running on different machines. So those applications probably independently developed by people who really know each other. So forth. And then somebody said, well, I really need to do this, put this together with that. Steps in order to really get the workflow in essence. Does and what other workflow composers do is it allows you to put all those things together into a composite application. That's the first Apache project. The second one is Apache Rave, which is software for enterprise social networking, shareable web components, and science gateways. Still founding members. What happened was, and I think it was 2010, I gave a talk to a working group of people who were all working with open social. Now, so we had a thing that you can still find on the website called the Gadget Container that we use to manage users and accounts and groups and also manage the displays of Google gadgets, open social, and Connect gadgets. So it turned out that there were, we had out after I gave the talk that there was issues. More or less. Anyway, so the three of us were invited by the fourth member here, by the name of Marlon, to form a new Apache project. So I've had a lot of experience. From scratch with Rave, so we decided even really in three different code bases to not continue by just one code base, but rather start from a completely new last count, including this is some screenshots of it out of date. Feel for what it looks like. So these are gadgets running on a pallet. They built on top of a thing called Apache Shindig. With the social networking. The idea of open social is they build gadgets. Also added REST APIs. All these things, there's a palette of these things right now. Group accounts, tabs and so forth. There's a widget that you can modify to make it easy to display, things like that. So it's actually becoming more than just that visual component, part because we chose Spring MVC as a framework that we're building on here. Besides just rendering being a thing that you can use to render gadgets, but what we're really growing into is a thing is a will do that, but you can also use Rave as a service provider for building any web application. It doesn't have to just be multiple components that have to a lot of magic that comes from Spring MVC, which is very easy for you to switch out. So if you don't like our user management or user service. Specification called these were actually very important. This is because if you're really going to do Apache project, starting out with 4 different groups in 4 different places, serve that in the Netherlands and writers and all these people have to live, they're living all over the world, have to figure out how to write. Working on your own code, and you're just building your own projects, it's very easy to get the code become a tangled collection of things. So your advisor says, you need to add this capability, or you need to look at doing this, or this is something you have to do. You're going to at some point look back at the code and say, wow, this has a really strange evolution. Earlier, my own example, can I really explain how my code came to be I did it to? So one of the things that, based on our need for working together all from the beginning with multiple sites of experiencing these kinds of things, all things that we had to do in order to have a project that was going to have a chance. Perfect design. I take the credit for that design, but I think we have a good design. How things are implemented, how pluggable. Look at the code. It's not trivial, but if you look at the code, hopefully everything is being added in the same pattern, following the same places are in the places you would expect them. Models in the places that you would expect them. Service to make it support grid authentication, that's the project. Exactly what to do. This is very important. Very important thing to have working with. The other thing is that Rave is really had a full paper at our GC11 workshop that presented 3 use cases about this, but Rave is really designed also that you can extend it without touching the source. A little bit about that. So I have more about it in the paper. Give you examples if you're interested. But the thing we wanted to do here is, if you want to add something, again, Rave is not built by just scientific don't know what X59 for certificate. Have a better life because of that. So we have to deal with those things. We don't want to pollute this general purpose code, very generic code base that does things in enterprise world. Why do we want to? We really want to have our X59 credential stuff sitting at enterprise. It's designed right in a way that you can basically create a skeleton project that has no Rave code in it except the code that you want to modify. And basically, you download Rave and install it, or soon you'll be able to pull the Rave release jars from the Apache repository. And the skeleton project, it just has your implementation of user service, it has your implementation of layout manager, it just has your version of something, and everything else that you wanted to inherit from Rave. Yes. I have plenty of examples of that. I won't say more about it because I need to move on to the last point I want to make, which is get back to the Apache way and science gateways. Apache or science gateways. Well, you can take this slide and read between the lines and say that I really think a lot of cyber infrastructure software not do any of this stuff very well. So, the first thing, as I mentioned earlier, to response to that question is that Apache is a neutral playing ground. Very important, I think, to find a way within cyber infrastructure projects which come from a particular place. There's some developer, some university that kind of owns it and holds it, and yet would like to keep it going and would like to bring people into the project. To do that, I think one of the things they have to do is figure out that they're going to have to give control over their project. Apache is the medium by which you do that. I would talk about it. I won't say more about it. I don't know anything in detail, but as I mentioned in response, it is designed as a way for big and small companies who normally compete with each other. The other big thing about Apache is that when they're slow over code, it's not really just about like they provide SVN and other tools like that, but it's really about the community of developers project, which jump from project, brought into one project, get involved in that, see some other project, use that as a springboard to get involved in social infrastructure that Apache not a like a related. First of all, the foundation itself is sustainable. 1999 is the biggest ones here, and so you can tell by some of these. Yahoo, for example, is not doing so well right now. Again, a company or else it can evaporate overnight, but none of these sponsors critical for Apache that they have enough. That comes from Apache. Lastly, as I alluded earlier, want to say, you can find out much more than I'll say here about program management in your POCs that to learn how to do this, though, all projects have to go through this phase. So the incubation phase is here. The Apache way is projects start out as an incubator with a champion and several years. So when they got it and make sure you're doing everything yours, but that running your group. Graduation is ultimately judged by the Apache community itself via is going through this right now. Decided that it's ready to leave. At that point, you have to demonstrate it to your knowing this is where all the needs to go through here and or through properly packaged code. It's not just build well, but stop licenses, frameworks, and so on. Look at either the Rave or the Airavata list, you'll find that Apache is really good. But if you're really going to release your code, developer diversity. So 30 developers all coming from IBM. Project typical requirements of 3 or more unconnected developers. But your champion and mentors will want to see is that you're not just starting out with the same people, start out as contributors, start out as bug reporters, patch reporters, things like that. Project is actually officially join the project. Growing your developer base and making it diverse is an important metric for graduation. Less than science anyways, again, Apache rewards projects for cross-pollination. Other Apache projects. Group of developers who have all to say about something. All the software, giving up all the Apache methods foster sustainability by building communities of developers. And here, you have to go through these open procedures. Apache contributions are just software. So, most of you here are probably programmers, but this is especially for ways in that not everybody that we deal with a lot of million people. Earlier, but he's not a Java programmer. So it shows we could make a case for him to join the project and although let's say in patches, do anything that needs to be done, and you can get loaded into the project. So I lied, there's actually 3 slides. This is the last one. Really want to get involved in our project or any Apache project. Welcome it and need it. And the way to do it is go to the developer list, grab software, start maintaining, post things to the developer list, post Jira tickets, and enough good fun report or good patch reports, you will start to gain the attention of the PMC, and you'll eventually get voted into the project. So thanks very much, and please let me know if you have any questions.
That project, you know, had multiple. The other one mainly started with.
So, Rave, of course, as you said, had several different people already involved, so we actually met the diversity requirement going in. Airavata was more typical. We had this point where we had some developer diversity. So the uptake is not at the level of Rave yet. Rave has become very interesting because people they know that, like in this last slide, you do this enough, and you can start getting involved. You can start. So with Airavata, what we've been doing is we have lots of collaborators, some of which are, if they're not the Java programmers themselves, okay, Barry's not, but he has Jerry Fang, who came from IU actually, is a Java developer, has some background in that. Dan is another guy who came from IU, who's working with now in Richmond, people like that. This is what we're trying to do is say, don't lurk on the mailing list, come out and post your problems to the mailing list, send all communications to the mailing list, and then don't take the code as it is. You have to fearlessly, there's plenty of problems, plenty of things on the Jira. All these people that we have in our own little Airavata world, get them anyway, it is a work in progress for this community. Really, I presented it as if it was already accomplished. It's really a work. I really should say all this is a work in progress, and we're really doing an experiment here to see if we can make it work and not do all. Who's the Apache license? I'm not a lawyer, but so don't take anything. If you take anything that I said seriously before, you can sure not take any of this that I'm about to say now. So the difference is that GPL is designed to be free software. It's designed to be zero, so it's a reciprocal license. If you build something out of GPL software, or build something out of GPL software, then what you build is now. It's not true for Apache. So Apache is designed not by guy, but it was designed by software. They also want to make commercial take the right product that the right parts of it don't have. Either the projects or branches. I don't know if it's Apache or not. We don't. Everything is, so in most projects, the Rave is a little bit more formal in this way because of this diversity. Everything is associated with Jira. Jira Epic. Put up into Jira stories, and each story has one or more actual tasks. Every single commit, so this is SVN. So every single commit is associated with one or more specific. Basically, to answer your question, it's not like all this discussion happens on the mailing list. In this case, you have a need for providing user profiles and connecting users together in the network. A feature that wasn't implemented until recently. So what we had was to start off by having all this discussed on the mailing list, stories around it, and each story got broken out into specific things that somebody had. Now they're just sitting there until somebody actually. So that is done by, so anybody who has commit access, anybody who's a committer on the project has right access to this. It doesn't have to be SVN, but most Apache projects. So if you're voted in as a committer, you get that right access. And then you can write crash code into the SVN. So it's not a, so the system for dealing with that is, for committers is actually people who are working with. If you commit code that should be there. For other people, what happens is you go through, and this isn't, a committer can do this also if you wanted to. You should want to. Apache has a review system. So if you go to list and say, I'm free to patch associated. Actually, I tried to see if we could get more than one person on one page patch. So basically, any committer can go and review your patch. Following that committer. So really, it's not a formal system, but rather it's because of that, we had a lot of people submit patches, and they all haven't been voted into the project. The reason is that we really need, once you get patch, in the patch system, you're really going to commit to the code. So I don't know if all Apache projects work that way. Let's wait.
What do you think, credit?
Credit. Yeah, so, well, you get a discount if you go to the Apache Con. It's a big discount too. They really milk the corporate people. Show up. So, yeah, I mean, that's the whole point, is that being a committer means you, PMC member, so PMC member also is a committer, but not vice versa. So if you're a committer, you get right access to the source code. Make commits directly to SPN. So you have a direct, if you're a coder, you have a direct say in how the code looks and what. So, of course, you shouldn't be doing that just awful and being a code cowboy and doing what you want. That's one of the benefits of being a committer. If you're in a PMC, you have another level of benefit in that you vote on the way the project releases are all voted on. Want to, so if we say, example, the other side I mentioned earlier, I thought it'd be nice if patches were reviewed not by one committer, but by two. So I put that up for a vote on the list as something that project two, it's not an Apache requirement, but it would be a internal requirement, and people didn't agree. Well, there were a couple people that didn't agree, most people just didn't. But once you're a committer, you have, or rather, once you're in the PMC, you have, when it comes time to make big decisions about things, you have a vote, and it's not just, yeah, so it's not, and it's not just, okay, let's add up all the votes, but rather, minus one really good minus one can outweigh a bunch of plus ones. If somebody has a deep concern about voted on, so let's say the release is really concerned about the release. This has actually happened too in these projects that I don't care about the legal issues and notices and things. The release do, and they look at these things very carefully. I will never do that. And they'll vote, and they voted minus one on releases because we didn't have our vote. Other people on the list said, well, okay, to this particular person who was reviewing the notices very carefully, other people said, okay, that's it. Other projects don't care about this. I've seen plenty of other Apache projects who don't have notice files quite up to date. But in the end, that minus one, even though there was only one person, and he could have easily been positive, it was enough. Reasons were enough that it issues worked out.
I mean, I just want to add just one thing coming at it. Big part of it. So. Do volunteer work. I think there's all sorts of pluses there. Yeah,
Willing to do volunteer work is.
What's that?
Willing to do volunteer work might be a minus though.
Well, might be a minus.
You get unpaid intern on something like that.
But anyway, I think we're out of time here, so.
Yeah, thanks very much.